In Chapter 7, Section 2, the normal distribution is introduced. The normal distribution is the most widely used type of distribution, and it has unlimited applications, as you will see later in the course. Characteristic of the normal distribution is that it has a bell shape. On the horizontal axis in a graph like this one, we measure the values of the variable, and the height of the graph, the height of the curve, represents probability distribution or probabilities. In the normal distribution, the value in the middle is the mean, but it is also the median and the mode. The normal curve is symmetric. In other words, from the dotted line in the middle to the right is exactly equal to the area to the left. As it extends to the left and as it extends to the right, these tails, in theory, never touch the horizontal axis. But that is not going to play a major role for us. Just be aware of the characteristics. Now going back one slide, as I said before, let's review this. Characteristic is bell-shaped and has a single peak at the center. It is symmetrical around the mean. It is asymptotic, in other words, never touches the x-axis. The location of a normal distribution is determined by the mean and the standard deviation. The mean is mu. Remember, that is the letter used for the population. And the standard deviation is sigma, which is also the Greek letter that is assigned for population, standard deviation. The mean, the median, and the mode are equal. As a probability distribution, the total area under the curve is defined to be 1.0, or is equal to 1. Because the distribution is symmetrical about the mean, half the area under the normal curve is to the right of the mean, and the other half is to the left of the mean. So in other words, to the left, the area should be 0.5, and to the right, the area should be 0.52. We find all kinds of normal distributions. The two parameters that define the normal distribution are the mean and the standard deviation. The smaller the standard deviation is, the more narrow the normal distribution will be. Or vice versa, the higher the standard deviation, the more wide the normal distribution will be. Here, for example, we have three different normal distributions. And they have a peak here. This one has a peak at 2000, this one at 2107, and this one at 2186. And they have also different standard deviations. This one here in red is more narrow than the one in green. The one in green is more wide. And finally, here at the bottom, you have three normal distributions that have the same standard deviation. All of them are about the same, have the same shape. And however, they have different mean, 283, 301, 321. So there is a family, as it says here on the slide, of normal distributions. In fact, you can argue there is an infinite family of normal distributions. There are all kinds of normal distributions because there are so many combinations of means and standard deviations. And that is the end of section 2.